In this microcontroller lab video, we are now going to look at how we can control a DC motor using the H-bridge. A motor is widely used in many applications where it provides an inertia and a rotation for moving an object, mostly in a process control plant, and many different applications where it requires a form of movement. And in this video we are going to look at how we can control this particular motor using a microcontroller. And most of this motor requires a driver, and we can now build our circuit. We can collect the Arduino Uno L293D, which is a driver for controlling a DC motor, and we can have the DC motor itself, and you can click OK, and let's place our Arduino. We can do our connection, and this driver is very important when we want to control the direction of the motor. And without this driver, it is quite difficult to control the direction and the speed of the DC motor. That is why the drivers becomes important when you want to control a particular motor. And we can now see that this particular DC motor can be able to control two sets of motor. One will be connected to out 1 and out 2, and we have the out 3 and out 4 which can be connected to a second motor, and this driver is called the L293D. And you have the enable 2 in 3 in 4, which is directly proportional to controlling the motor connected to the output 3 and 4. And we have the enable 1, input 1 and input 2, which is the control input for the motor connected to output 1 and output 2. And this driver is made up of the 8 grids, and we can now be able to do a simple connection, and from there we can program how a microcontroller can be able to control the direction and the speed of this particular DC motor. And if you want to check the components such as the rating of the motor, you can double click on any other component, and it is operating at a nominal voltage of 12 volts. If you want to increase or decrease the voltage for your simulation, you can change the values here. And we now can have the power, which is the power that is required to drive the motor, and it is not a signal. There is a difference between what is a signal and what is a power. A power that is required to drive this motor is 12 volts. Therefore we can click 12 volts, which is the power supply to this motor, and VSS is the power supply for this particular L293D drivers. And we can connect a 5 volts to power these particular drivers. And in order to make a particular input active, we have to have the enable, which must be high. If the enable is low, it will disable the input pin. Therefore, it is important you supply a 5 volts to the enable pin so that it will activate the input signal to input 1 and input 2. And we can connect this to so we have the input 1 connected to pin 6 and the input 2 to the drivers, which will control the operation of the DC motor, and input 2 is connected to pin 5. And this is our circuit diagram. And finally we have to connect the ground, and we can just leave this one empty because we are not using another motor for this connection. We are using only one motor. And this is our circuit diagram, and we can program this microcontroller for a specific code that can control the direction or the speed of this DC motor. And later on, if we want to add more control, such as adding a push button or adding a graphical user interface, then it is possible, in which by clicking those buttons or external peripherals as an input device, we can now control the movement of this motor. And this simple video as a beginner's guide can help you to improve your knowledge later on if you want to design something with respect to the use of the DC motor. Now let us open up our Arduino IDE and we can start to program. Now our IDE is open. We can zoom this one a little bit so we can see the connection. And now we are going to initialize the pin that is corresponding to the input to the H bridge, which is the L293D. And we can be able to specify this pin as an integer, let's say input 1, which is corresponding to pin 6. And we can say into, which is corresponding to pin 5. Now in this case, we are assigning an integer value which is for in one of these particular H-bridge drivers where it is connected to pin 6. Therefore, this is a variable where the data or the signal that will be passed to pin 6, which is connected to in one of these L293D drivers, this signal will be stored in the variable type integer with the variable name in1. And the signal that will be passed to pin 5 of this Arduino, those signal as an integer value will be stored in the variable name in2, where it is a variable type integer. And now we can go to the void setup, and under void setup we can declare pin mode such as in1, which is the output pin, where all the signal that to be passed at this particular pin will only be the output signal. And we can say pin mode in2, which is also the output, where it will not be accepting any signal as a digital signal from the pin 6 and pin 5. So pin 6 and pin 5 will mostly act as a output. That means they will only give the signal as an output. And once we are done by declaring the pin as an input and output, we will now be able to control this particular motor. When we talk about the rotation have a direction. If we want to have the motor operate in a clockwise direction, then we can write the code respectively. And if we want to enable the motor to operate in a anti-clockwise mode, we can also program by giving this specific instruction. And it is mostly defined as sending a signal to each of these input of the 8-bit. Now let's see if we want to control this clockwise. That means we have to apply a signal I to the input 1 of these 8 bits, and from there we can have the rotation which will be clockwise. And if we apply a signal to the in2 of these 8 bits, we are now enabling the drivers to send a signal to the DC motor to operate in the anti-clockwise direction. So let's see how we can do that. And if we give a comment and we say rotate clockwise, first we want to rotate this particular DC motor in the clockwise direction. And in that case, we normally send a signal such as digital write. And digital write mostly send out a signal in terms of binary 1 or 0, when we say binary 1, it will output a 5 volts to the output, which is connected to the in 1. Therefore, we can say in 1 equals to high. We are sending the logic 1 to the pin 6 of this Arduino Uno. And when we say digital write, where we have IN2, which must be low, because for the direction both of them cannot be high, because this driver will be confused whether it will turn in the clockwise or anti-clockwise direction. And it is important that when one direction is on, the other one must be off. Therefore, we have I, where it is sending a signal to the in one of these drivers to rotate this particular motor in the clockwise direction. And these drivers will provide, after receiving the input of logic 1 to in 1, it will generate a signal to control the motor to operate in a clockwise direction. Therefore, the driver is very important when it comes to the control of a DC motor. Now we can add a delay of, let's say, 2000 milliseconds, which is corresponding to 2 seconds. And in this code, we want to enable the rotation to the clockwise by only 2 seconds. And after this, we can now say digital write IN1, which must be low. In that case, we are now stopping the direction, and we can say digital write IN2 must be low. That means both direction will be disabled, and we give a delay of 1000 milliseconds. This is in terms of 1 second. So in this case, we can say stop the motor. And when there is no signal to both the input 1 and input 2 of this particular 8-bridge drivers, there won't be any movement of this motor. That means it is initially we are switching off the motor. And if we say, if we want to rotate in the anti-clockwise direction, let's say rotate anti-clockwise, and from there it is simply we can now be able to send a signal digital write. Let's say IN1 must be low, because when it is high, it will control the motor in the clockwise direction. And we can have digital write, and we have IN2 must be high, and this is the signal that will enable the H-bridge to control the motor to operate in the anti-clockwise direction. And we can give a delay of 2 seconds, and finally we can say stop the motor again, and we can write again the digital write, where we have IN1 must be low, and both of them must be low, and we can have digital write IN2 must be low, and let's give a small delay of 1000 milliseconds, which is the 1 second. And in this code, if I can explain, where if we pass a 5 volts to the input 1 of this H-bridge, then it will enable the H-bridge to generate a signal that will control the direction of the motor to operate in the clockwise direction, while we have the input 2, which is low. That means no signal is passing through the input 2. And after the 2 seconds, it will now enable both input 1 and input 2 to be low. That means no signal to control the operation of the motor, meaning that the motor will be stopped because there is no signal for whichever movement for it to occur. And similarly, we can be able to see that when we want to operate in the anti-clockwise direction, we make sure that the input 2 of this H bridge is high and the input 1 is low, and this H bridge will now generate a signal to control the operation of the DC motor to operate in the anti-clockwise direction. And then we have this code here which will stop the rotation of the DC motor, and since it is under the void loop, that means it is a continuous loop, so it will continue to operate such that it will turn in the clockwise direction for 2 seconds and it will stop for 1 second, and then it will rotate in the anti-clockwise direction for another 2 seconds, and then it will stop again with a delay of 1 second. So this is our code. Let's compile to see if we have some errors. When no errors are found, we can now go to export compile binary, and we should have our hexadecimal values ready for this Arduino. So we can click this one, we go to code, and we can import our code, and okay, and we can run the simulation to see how this operates. Now you can see it is operating 2 seconds and then off, and it is now in the anti-clockwise. After 2 seconds it will operate anti-clockwise. The important thing you can identify from this motor, when it is in the clockwise direction it will be positive, and this represents the speed of this particular DC motor, and when it is in negative, that means it is in the rotation is in the anti-clockwise direction. And this is how you use the H bridge to control the direction of a DC motor. So this is a basic idea to use a DC motor control with the H bridge. Later on we will add some control to see how we can use some interface to control how the motor will operate in terms of its direction and speed. So I believe if you learn something about this video, you can use this code as a basic ideas into how you can control different kind of a DC motor using the DC motor driver, which is L293D. So there are a lot of applications which require the use of a DC motor, and this basic can help you to build from there. So I hope you like our video. If you want to know more of our content, you can kindly like our video, share and subscribe to support our channel.